Hello class, this is Mr. McAllen, and I just received an email from a couple students saying that they were drawing a blank on how to work through problems 18 through 24. So this is just hopefully going to be a 5-minute video on how to find trig ratios for quadrantal angles or common reference angles. So the first thing you need to do is, on each one of the angles that I give you, you've got to determine if it's a quadrantal angle or if it's a common reference angle, meaning 30, 45, or 60 degrees. And we have a few ways to do that. So first of all, let's just look at the problems that we have ahead of us. And if you look at the angle value, like 90 degrees, if the angle lands on a quadrant line, for instance 90 degrees would be a quadrantal angle. It would start at 0 and go to 90. Then you're going to have to use the table or chart that we discussed in class. If you're in radian amounts and the denominator is equal to a 1 or a 2, then you're also on a quadrantal angle. For example, the sine of 3 pi over 2, that would be the angle that is aligned with, starts at 0, goes around to 3 pi over 2 radians. That would be a quadrantal angle. So you would want to use the chart that we talked about and identify the sine of 270 degrees or 3 pi over 2. So I'll just draw that chart just so that you have it. But it's very important that you understand when to use this chart and when not to. So we have 0, 90, 180, 270, and 360. And then the values will repeat themselves. So the sine ratio will follow, it will start at 0, go to a maximum value of 1, come back to 0, go to -1, and then go to 0 again. Remember, the sine ratio deals with the y coordinates. Cosine would start at 1, then proceed through the following values. And then the tangent ratio is the quotient of the sine ratio over the cosine ratio. So you just look and you say 0 over 1 is 0. Undefined, 0, undefined, 0. So for the cosine of 90, we would just recognize that to be 0. And for other quadrantal value, the sine of 2 pi, that's the same angle as when you're at 360 degrees. The sine of that would be, or the same as sine of 0, that would be equal to 0. Now let's look at how we handle the common reference angles. For instance, we have the cotangent of 120 degrees. First, you have to draw a 120 degree angle in standard position. You have to draw the reference angle, which would be 60. And now you have to draw in the vectors for the sides of this 30, 60, 90 triangle. For instance, we have a side of -1 here, a side of √3 going up, and a side of 2. So the cotangent would be the adjacent over the opposite, -1 over √3, and you would rationalize that to give you -√3 over 3. let's look at the sine of 150. You draw an angle in standard position, 150 degrees. The reference angle would be 30 degrees. And you would draw your sides to be +1, -√3, and this would be 2. And the sine ratio for that 150 degrees would equal 1/2. Let's take a look at how we take care of the sine of 2π/3, number 21. Now this is a little bit different because we're dealing with radians, and I've told the class that radians are actually easier than degrees because the denominator gives away the reference angle. Because there's a 3 there, the reference angle is 60 degrees. And we have to estimate that this angle is at the 2 radian mark, because 2 times 3 divided by 3 would be approximately 2 radians. And we know 2 radians is in quadrant 2. So this is the angle 2π/3. We know that this angle here is 60 because of the 3 in the bottom. So we end up having, this is √3, this is -1, and this is 2. So our sine of 2π/3 is going to equal √3/2. The next one, number 22, is tangent of 5π/4. Again, the 4 indicates that we have a reference angle of 45. The 5π/4 tells us what quadrant we're going to be in, so we're going to estimate that. Estimate pi to equal 3. It's 3.14, but we'll just use 3. So 15 divided by 4 is approximately 3 3¾ So we know we are in quadrant 3 because our quadrants go 0 radians, 1.5 radians, approximately 3 radians, and this is 4.5. So we know that our angle is going to be in standard position in quadrant 3, and that's going to equal, oh, I'm sorry, that's a 45, 45, 90, so that's going to be, let me just change the ink color so that it's easier to see. So that's going to be -1 because it's pointing left, -1 because it's pointing down, √2. So the sine of that angle, or the tangent, because it asks for the tangent of 5π/4, is going to be -1/-1, which will just be equal to 1. Looking back, let's find number 23 says the sine of 4π/3. Again, we draw a reference angle. We've got a 60-degree reference angle. This time, 4 times pi divided by 3 puts us in, so you got to figure out where you are radian-wise. So radians, or the angle, says that 4 times pi divided by 3 is the same as 4 times 3 divided by 3, so we're at 4 radians. That will again put us in quadrant 3. This is 60, and the sides of this triangle are going to be -1, -√3, and 2, and we know that the sine of that ratio will be -√3/2. Last problem, and you'll be happy to hear my voice end, cosine of 4π/3. Oh, look at this. I think it's the same angle. It is, so that's terrific. Cosine of 4 pi over 3, I can use the same diagram as up here, and that's going to equal, the adjacent side is -1, the hypotenuse is 2, and that's my trig ratio, -1/2. Hopefully this has helped you refresh your memory for how to find trig ratios without a calculator, and I look forward to your comments tomorrow in school, and I'm just going to post this link on the WordPress website. Thank you, and take care. Good night.